Okay, so x minus 6, and then you've got x squared plus x minus 6 plus x minus 3 or x squared minus 1. Okay, so common, when we're adding and subtracting, we need common denominators. So to know what the common denominators are, we've got to factor this down and that one. So we have two sets of parentheses and another two sets of parentheses. What are my signs going to be on this? Signs. Plus and a minus. Okay, this is an x, this is an x. We read this backwards. What are your factors of 6? Subtract, give you 1. 2 and 3. Okay, where do I put the 3?
The plus.
Right, so it's whatever the sign of your second term is. So the 3 goes there, and then 2 goes there. Okay, signs?
Plus and minus.
It's different. Let's put in my x's, and the square root of 4 would be 2. Okay, so now we're looking for common denominators. So this one has an x plus 3, but that one doesn't. So that means I would need to multiply the bottom, but not literally don't multiply the bottom. That's the one that would take forever. Okay, but whatever we do to the bottom, we've got to multiply the top. So the top, you definitely have to multiply. Okay, so x plus 3, x plus 3, x minus 2, and x minus 2. So this one's missing the x plus 2, right? Okay, so we have our 3 parentheses. We use those alone, because otherwise you're taking more time during the test than you need to. So the denominators will be those 3. But we've got to distribute this numerator and this numerator before you combine the 2. Okay, so x times x would give me x squared. That gives me 2x. That gives me a negative 6x. Good, negative 4x. Okay, negative 6 times 2 would be a negative 12. Okay, so we're done with that. So now this one. So x times x would give me x squared. 3x and a negative 3x. Right, 0x. Okay, and then a negative 3 times 3 would be a negative 9. Okay, so combining our like terms, I have 2 of them, right? So 2x squared. I didn't have another x to combine it with, so it stays a negative 4x. And then a negative 12 and a negative 9 would be a negative 21. Okay, over your common denominator. Okay, so you have a fraction and then those 3 parentheses underneath it. You see what we did? Yeah. Okay. Any others? Yes.
Number 7.
7. Okay. Good. That seems to be the one that where you're missing. Okay, number 7. So x plus 3, x minus 3. So I didn't have to factor any of those. Okay. Keep its division. So keep dot and then flip it. So what's at top is x squared minus 9, so it's going to be at the bottom, which means I need to factor it. Okay. So it's a minus 9, so it's going to be a plus and a minus, and then the square root of 9 would be 3. Okay, so the one that was at the bottom that's going to go to the top, we have to rewrite it. Okay, and this is what it was. But if you notice, all the things that we have, it starts with a positive x. We want to rewrite it because we want to be able to get rid of it. So I want a positive x. So to make that positive, I have to take out that negative 1 so that I can rewrite it. Okay, and that would switch that to a positive x, but that would switch that positive 3 to a negative 3. And so if you were to distribute this, it gets you back to the original. Because negative 1 times x is negative x. A negative times negative is a positive. We just rewrote it. Okay, it's still the same thing. Okay, so do we have to find common denominators?
Yes.
Yeah.
No.
No. We cross cancel. So when it's adding and subtraction, you do. Okay. So now we just look for anything on the top and the bottom that are the same. And people were getting confused. They thought it had to be in the same fraction. It doesn't. It's any top with any bottom. So it could be diagonally or in the same one. Okay. So x plus 3, x plus 3. X minus 3 can go with that one or that one. Doesn't matter, as long as you only go once. Okay, so what's left at the top? Negative 1. And at the bottom, every single time that pattern is the same, other than the numbers. Okay, others. Yes.
So I just have a question about for the addition and subtraction ones. How do we know if your like answer is going to be like positive or negative? Like I know like addition and subtraction is just confusing.
Okay, so let's do. I'm not sure what you're. So I'm going to do number 1 just to see if that clarifies.
Yeah, like the difference between the addition and subtraction ones.
But there isn't a difference that we're doing the same steps. but you might be multiplying a negative to a negative or a negative to a positive, so you have to just pay attention to your signs. Okay, so this is number one. And we'll see if this answers your question, you can be more specific with it. Okay, so adding and subtracting, there's no multiplication of this, we have to find common denominators, okay? So this one's been broken down, but this one needs to be broken down. Okay, so any that have the x squared, you've got to factor. Okay, so signs are the same, they're both going to be a plus. Okay, factors of 20 to add 59. Right. Okay, so the denominators have to be the same. So this one has an x plus 5, this one has an x plus 5. This one has an x plus 4, but that one doesn't. Okay, so I would need to multiply the bottom. Okay, whatever I multiply, I've got to do the same thing to the top. Okay, so now my denominators are the same. Okay, so I have, and it doesn't matter which one you write first. And again, on the test, don't waste your time distributing this back together. Like, you're done with the denominators, but we have to do that to the top. So I didn't have to change anything to this one, right? So that one stays the same. Okay, but this one has a -2, so I have to distribute that -2 to both of those things. Okay, so a -2 times x would be a negative 2x. A -2 times 4 is going to make it a -8. So now you combine your like terms. Well, that one didn't have one, so it stays the same. But these guys are like terms, so it'd be a negative 11.
Okay, so basically, if it's a positive, it'll be a +2. This is subtraction, it's -2. I see.
Right.
And then
Because you're distributing a negative. Where before if it was plus, then it'd be +2 times x, which is +2x. Yep. Good? Okay, any others? See the test tomorrow. Okay, so what I did in every single geometry class today is whatever questions were asked, regardless if it was the same problems. Hold on, I gotta stop this video.